5 miles west at 1,700, frequency change bird.
And M1.
Tobin 69, report initial.
Tobin 69.
The American fighter, immortalized in movies, and the backbone of United States foreign policy. This F-16 Fighting Falcon is an example of America's technological prowess and a source of pride for its Air Force. A sleek, lightweight airframe allows pilots to turn faster and tighter than opposing planes. The ability to bomb targets, as well as shoot down other fighters, makes the F-16 one of the best multi-role combat aircraft in the world. Conceived in the wake of the Vietnam conflict, the Air Force said it wanted a light, single-engine fighter that could dogfight, as well as destroy ground forces. The F-16 is so popular that it serves in many countries throughout the world. It was proven in battle with the Israeli Air Force and was a vital tool for the United States in the Middle East. The F-16 has been constantly updated and given new missions and abilities, ensuring that it will serve well past the year 2000. The United States Air Force has enjoyed a reputation for cutting-edge aircraft since World War II, and American designers have set the standards for air dominance for more than 50 years. Although today's Air Force utilizes dynamic airframes, groundbreaking avionics, and stealth technology, the United States entered the century as only a minor player in global events and aviation, even though they were the first to introduce powered flight. The U.S. was slow to embrace the airplane, and by 1914, America found itself behind its European counterparts. But World War I would begin to change all that. With one shot, Archduke Ferdinand was assassinated in Bosnia, and all of Europe was caught up in the fire of war. The airplane was a fledgling technology, but it was immediately thrust into the war for reconnaissance duties. But soon airplanes were fitted with machine guns, and the fighter aircraft was born. Pilots who shot down 5 or more enemy planes were called aces and were seen as the knights of the 20th century. The adulation knew no borders. French morale was bolstered by the successes of Georges Guillemer and René Fonck. Germany's Oswald Boelcke developed basic rules of aerial combat that are still taught in today's fighter schools. His protege, the legendary Manfred von Richthofen, terrorized Allied squadrons in his Fokker triplane. Richthofen recorded 80 kills before his death, more than any pilot of the war. His enemies and compatriots nicknamed him the Red Baron. Aces are remembered as chivalrous warriors of a romantic era, but air battles were fought to the death. Few aces survived the war. Their contributions to aerial warfare endured forever. America, neutral and indecisive in world events, didn't enter the war until the final year, using borrowed French and British planes. America's leading manufacturer, Curtiss, built Jennies for reconnaissance, but the U.S. had no fighters of its own. After the war, the United States used European technology to lay the foundation of its aviation industry. Boeing and Curtiss supplied the Army with its first domestic pursuit planes. The military still viewed aviation with caution, but the American public quickly fell in love with powered flight. In the 1920s, World War I pilots began touring the country, entertaining crowds with races and stunt flying. Americans turned out in record number to watch wing walkers, and racers risk their lives and shatter speed records. Sponsored by private corporations, these aerial gypsies were flamboyant and charismatic. They began racing for prizes offered by wealthy businessmen who were fascinated with the new sport. The National Air Races saw an annual speed competition for the Thompson Trophy. Jackie Cochran, Roscoe Turner, and Jimmy Doolittle became national celebrities as they broke records year after year. Britain and America dueled every year for the Schneider Trophy, an international speed competition. The end of the 1920s saw racers passing 300 miles per hour. In 1931, the Supermarine S-6B with a Rolls-Royce engine won the trophy at 404 miles per hour. This plane would later be outfitted for war to become one of Britain's legendary fighters, the Spitfire. The American fascination with flight did more than make headlines. The period between the World Wars saw dramatic leaps in speed, engineering, and technology. Navigational instruments enhanced safety and enabled pilots to fly at night. Engine designs were improved to cut down on weight and provide more horsepower. All of these advances were installed in pursuit planes, preparing America for the political eruption in Europe. With war clouds on the horizon, a number of American companies began submitting designs. Bell, Lockheed, Northrop, McDonnell, Republic, and Vought all contributed to airplanes. The bombing of Pearl Harbor drew America into the war with Japan and Europe. For 4 years, some of the premier fighter planes were the British Spitfire, Germany's Messerschmitt Bf-109, the Focke-Wulf 190, and the Japanese Zero. Some of America's contributions in the war were the P-40, P-38, P-47, and P-51. Hitler believed that Germany was an unrivaled military and industrial power. The German Air Force, known as the Luftwaffe, was a top priority of Germany's military planners. Its leading fighter manufacturer, Messerschmitt, would make incredible aerial advancements. It produced the Me-109 in 1935. It wasn't invincible, as Hitler believed, but many Allied aircraft would fall to seasoned German pilots. The Focke-Wulf FW-190 arrived in 1941 and challenged the best fighters the Allies could offer. Both planes were superior when they first took to the skies, but the Me-109 and the FW-190 would soon be challenged by the introduction of new Allied fighters. In the Pacific, the Mitsubishi A6M-0 provided the Japanese with air superiority for a short time. Light and quick, veteran Zero pilots confounded the Allies with aerobatics and skill. The lack of armor and self-sealing fuel tanks were its greatest weaknesses. The Allied powers won the Pacific with sheer numbers. The innovative Lockheed P-38 Lightning was the first twin-boomed fighter to go into production. German pilots dubbed it the twin-tailed devil. The Lightning exceeded 400 miles per hour, making it the fastest plane available. Its unusual shape hindered inexperienced airmen in a dogfight, but with time, Lightning pilots learned to love the radical design. The top American ace of World War II, Richard Bong, shot down 40 enemy planes in a P-38. Charles Lindbergh showed pilots how to conserve enough fuel for 12-hour escort missions in the Lightning. In April 1943, 16 P-38s destroyed the transport-carrying Japanese naval commander Yamamoto, the mastermind of the attack on Pearl Harbor. The first American plane to battle Axis air power was the Curtiss P-40 Tomahawk. In 1941, General Claire Chennault and 80 volunteers left the United States and traveled with their P-40s to China. Proclaiming themselves the American Volunteer Group, they were nicknamed the Flying Tigers. With shark's teeth painted on their planes, they were the first American unit to take on Japanese Zeros. Although the Zeros were more agile than the Tomahawk, the Flying Tigers pioneered new tactics. Chennault's men destroyed nearly 300 Japanese fighters before the United States officially entered the war. The tough yet aging P-40 anchored the Pacific and African air units until more sophisticated fighters could enter the war. Many viewed the P-40 as too slow and heavy to continue winning battles, but it served as an important training tool. American Tomahawk pilots had to rely on strategy in order to beat Axis interceptors, and those methods would be built upon when higher performance fighters reached the front lines. Over 15,000 Republic P-47 Thunderbolts were produced, more than any other World War II fighter. Designed as a long-range bomber escort, the Thunderbolt protected pilots by absorbing enormous damage. On one mission, P-47 ace Robert Johnson's Thunderbolt took over 100 machine gun bullets and 21 rounds from a 20mm cannon. Incredibly, Johnson made it back unscathed. When Americans realized that enemy pilots could outmaneuver the Thunderbolt, they took advantage of its high-altitude performance, diving fiercely on German interceptors. P-47 pilots destroyed 5 Axis planes for every Thunderbolt lost. Although the P-47 was designed for high-altitude flight, pilots also hit essential ground targets. Equipped with bombs and rockets, Thunderbolts pounded trains, tanks, and supply trucks. North American aviation contributed an aircraft that was so advanced, some historians would claim it was the best propeller-driven fighter ever to see combat. The P-51 Mustang was fast, quick, and armed with 8 guns. Mustangs were also multi-role aircraft, guarding long-range bombers and attacking ground targets. P-51s destroyed over 9,000 enemy planes in the air and on the ground. Mustang pilots even downed a few Me-262s, Germany's first jet fighter, and 230 V-1 flying bombs. Once the airframe was united with the British Merlin engine, the Mustang became the premier American fighter of the war. The German Messerschmitt Me-262 became the first jet fighter to enter service. It arrived too late and too few in number to help Germany, but it would leave a lasting impression on the world. After Germany's surrender, Nazi advances in aviation shocked Allied forces. German engineers had also developed delta wing and tailless designs. The Me-163 Comet was created as a rocket-powered interceptor. Pushing past 700 miles per hour, the Comet would have wrought havoc on Allied bombers had Hitler made it a top priority. The ramjet was being designed at the end of the war and would have allowed German jets to break the sound barrier. Britain, America, and Russia scrambled to exploit the new technology. In World War II, Russia had borne the brunt of Nazi war power and barely survived. Joseph Stalin was reeling from the carnage of war and resentful of his Western allies. He vowed to never be vulnerable again. After the war in Europe, Berlin was carved up and occupied by Allied forces. Stalin cut off all traffic to the eastern sector and quarantined the Russian portion of the city. Western forces watched helplessly as the Soviets engulfed portions of Europe, which were absorbed into their communist sphere. When the Allies had met earlier, former British Prime Minister Winston Churchill had hoped an Iron Curtain would not descend across the continent. Although the United States had been suspicious of Stalin, they could not predict that for 30 years the two superpowers would be embroiled in a Cold War. the Soviet Union shrugged off huge war debts to the United States. New American President Harry Truman was outraged. He declared that unless Russia was faced with an iron fist and strong language, another war would be in the making. To end World War II, the United States forced Japan's surrender by employing the atomic bomb, twice. America held the most destructive weapon in history and would continue to develop nuclear weapons in great numbers. 4 years after the end of the war, it no longer had a monopoly on mass destruction. In 1949, Stalin declared that he too had nuclear capability. Stalin died in 1953. Nikolai Khrushchev, his successor, continued the military buildup. An ongoing game of one-upmanship ensued on every level. Money for research and development flooded American industry, and the fear of Soviet invasion sped up advancements in fighter technology. American engineers constantly broke new ground as companies were pressured to make new concepts a reality. Money was poured into jet development, and with Britain's help, the P-80 Shooting Star and P-84 Thunderjet entered service. The jets were heavier, faster, and could handle more weapons than their propeller-driven predecessors. Pilots had trouble adapting to the new breed of fighters, and mishaps were inevitable. Despite heavy losses during training, the Air Force was confident in its new jet aircraft. The Air Force was content with the traditional straight-wing design that had lifted so many wartime fighters to the battlefront. There were others, though, who were seeking to push jet performance even further than their Western rivals. In 1951, the United Nations went to war in Asia, squaring off against communist North Korea. American straight-wing jets were confronted by the sleek, swept-wing MiG-15s supplied by the Soviet Union. The military didn't believe the Soviets could produce such a sophisticated aircraft. Many were shocked by reports of its performance. North American swept-wing F-86 Sabre was quickly introduced into the war to even the terms. Sabre shared the MiG's wing design, letting pilots turn and roll at higher speeds. Combined with a large nose intake, the planes looked dangerously similar.
Got a couple bogies out there, one coming around at 2 level. Roger, boy, I got him.
Both aircraft were almost evenly matched, but it was pilot training that made a difference. American pilots had the experience of World War II dogfighting under their belts. Korean and Chinese pilots had less training and discipline. As a result, American Sabre pilots enjoyed an 8-to-1 kill ratio.
Hang on. I haven't done it, but go ahead, take it, and I'll cover you. All right, I'm going in now. He's down, boy, you got him too.
Before Korea, the United States believed that Soviet technology lagged far behind American capabilities. The MiG-15 made it clear there was a real threat to Western supremacy. American military planners were obsessed with the Soviet expansion and vowed to check communism in all corners of the globe. The U.S. stayed on 24-hour alert while they built up their fighter squadrons to ward off attacks from bombers or intercontinental ballistic missiles from their enemy. The need for fast, high-tech interceptors gave rise to the Century Series aircraft, planes with a 100 designation number. Equipped with radar, new weapons, and automated controls, these fighters brought about a dramatic escalation in costs. Specifications included multi-role demands. Every interceptor had to be capable of carrying nuclear weapons. What the Soviet Union perceived as a genuine threat American military planners believed the Century series was worth every penny. The development of air-launched rockets that could travel great distances and guide themselves to a target was given top priority. These technical advances in weapons turned American fighters into high-speed missile platforms. United States Air Force commanders believed that dogfighting was outmoded and that pilots should be trained to shoot down invading bombers. Guided missiles were considered so effective that pilots could shoot down bogies without even making visual contact. The philosophy of fire and forget replaced skilled piloting. North American expanded on its F-86 platform to create the F-100 Super Sabre. The F-100 retained the Sabre's nose intake but was longer and more aerodynamic than the F-86. The Sabre could break the sound barrier in a dive, but the F-100 was the first American interceptor to exceed Mach 1 in level flight. The Super Sabre also broke financial barriers with its titanium construction and new avionics. An autopilot was installed, along with radar and a low-altitude bombing system. For 1953, the Super Sabre was so far ahead of its time that President Eisenhower awarded North American Aviation and their chief engineer, Dutch Kindleberger, the Caliber Trophy. The F-100 was more than a technical achievement. It was built to last. Super Sabres played an important role in Vietnam. Nicknamed the Hun by its pilots, the plane served as the first Wild Weasel Squadron in Asia. These daring pilots hunted and destroyed Vietnamese surface-to-air missile sites. F-100 losses were very high, but Wild Weasel missions were instrumental in protecting fighters and bombers. These workhorses would serve on the front lines until 1971, leaving a distinguished 18-year career behind them. Republic finished the F-105 Thunder Chief in 1957. Designed 4 years earlier for the Korean War, the F-105 was adapted as a multi-role fighter, able to dogfight and deliver nuclear payloads. In 1965, the Thunder Chiefs, nicknamed Thuds by their pilots, would be sent to Vietnam. They achieved a handful of MiG victories, but were largely ineffective against the Soviet-built MiG-19s and 21s, so they were relegated to hitting ground targets. When the F-105 was introduced, it was the largest fighter in the Air Force's inventory and could carry more bombs than a B-17. The Thunder Chiefs were eventually handed over to Wild Weasel crews who were grateful to fly a Mach 2 attack aircraft. The F-105s and the new Shrike missile made the Weasels much more effective at killing surface-to-air missile sites. Even with the 105s, the gutsy Weasels suffered devastating casualties. Guided by their motto, first in, last out, they intentionally drew ground fire to guard Phantoms and heavy bombers. The Air Force lost over 350 Thunder Chiefs and the brave men who flew them. Back in 1948, Convair, the Air Force, and German designer Alexander Lippisch teamed up to construct America's first Delta Wing research aircraft, the XF-92A Dart. The triangle wing and vertical fin would allow better stability in supersonic flight and at high altitudes. The wings could be thinner and hold more fuel. The test plane never broke the sound barrier, but the new principle called Area Rule helped Convair streamline the airframe. Tests of the Dart were so encouraging that orders were immediately given for production design. Aerodynamic and engine problems stalled the arrival of the F-102 Delta Dagger until 1956. The F-102 was longer than its experimental predecessor with a sharper nose and side air intakes. It was the first interceptor built without a gun, which was deemed useless for the job of a long-range interceptor. Rockets and missiles were fired from an internal weapons bay. It was America's first all-weather supersonic interceptor. Hughes Aircraft Corporation was awarded a contract to develop new weapons and electronics for the Delta Dagger. With both the F-102 and Soviet bombers flying in excess of Mach 1, pilots were no longer trusted to accurately target and fire weapons at such high speeds. The MG-10 flight control system would coordinate with ground controllers to fix an interception course with the target and destroy it. The performance of the airframe and the automated systems never measured up to the Air Force's expectations, and the F-102 was declared an interim fighter, one that would suffice until the arrival of the F-106 Delta Dart. The F-102 defended the northern frontier before being shipped to Vietnam, where it would serve until 1968. The F-106 Delta Dart was much more than an updated model. With a more powerful engine and redesigned intakes, the F-106 could soar beyond Mach 2. The F-106 was an integral facet in the defensive net surrounding the United States borders. The North American Air Defense Command coordinated efforts to detect and destroy attempts to bomb American soil. Fighter squadrons in Alaska were kept on 24-hour alert. If a threat was ever detected, the Delta Dart could carry a nuclear-tipped Genie air-to-air missile capable of taking down an entire formation of enemy bombers. Pilots believed using the Genie missile would be a suicide mission, so Hughes needed to automate the F-106 even more than its predecessor. In the event the Genie was fired, the F-106 would automatically bank hard to avoid the blast. Computer networks linked the plane to ground controllers, who would exchange identification and targeting information with the pilot. Its MA-1 navigational system allowed the F-106 to be remotely controlled, engage in battle, and even land without the pilot. If the pilot were exposed to radiation from destroying a nuclear bomber formation, the Air Force would be able to get him and the $1.2 million airplane home safely. The F-106 entered service in 1959, but an emphasis on nuclear missiles would stop production 2 years later. The rugged and maneuverable Delta Darts would serve for almost 30 years, last flying for the Air Force in 1988. The McDonnell F-4 Phantom was America's premier air dominance fighter. It was chosen by the Air Force, Marines, and Navy to face Soviet-built MiG-19s and 21s in Vietnam. The Phantom had broken world records for altitude, speed, and acceleration. It had computer-controlled air intakes, state-of-the-art navigation, and weapon systems. Like the Century Series planes, the Phantom was tailor-made to shoot down a bomber, but it struggled with the MiGs. America had all of its faith in guided missiles, so much so, the first Phantoms didn't even have machine guns or cannon. The MiGs were light, fast, and very nimble. U.S. pilots found the guided missiles did not meet their lofty expectations. Pilots taught to shoot down opponents from miles away found their missiles of little use when the enemy could maneuver into close proximity. American pilots would have to return to the basics of dogfighting. Guns were installed on later F-4s, and the fire and forget philosophy was discarded. The kill ratios rose to 3 MiGs shot down for every 1 Phantom lost. Today's collection of American fighters still bear the marks of the Cold War. In the 1960s, the United States continued to think in terms of bombing the Soviet mainland, despite its involvement in Vietnam. North America's heavily funded XB-70 Valkyrie was projected to be a Mach 3 nuclear bomber. Traveling higher and faster than any fighter plane, the Valkyrie was designed to haul 25 tons of nuclear bombs 15 miles high. The project was canceled due to several accidents and cost overruns. but not before the Soviets built a plane to catch it. The Soviet Union responded to the XB-70 at their 1968 air show with the MiG-25 Foxbat. The Foxbat was to be the fastest fighter in service for either country. It had only one mission, defending Soviet soil from the feared Valkyrie. Its speed approached Mach 3 and could climb to incredible heights. After outrunning an Israeli Phantom in the Middle East, NATO officials went into a panic. The U.S. government demanded a solution, and McDonnell Douglas answered with the F-15 Eagle. Exceeding Mach 2.5, the nimble Eagle was built to challenge the Foxbat in a dogfight. Variable air intakes and a large air brake allowed the Eagle to outmaneuver planes half its size. This Northrop F-5, the quickest American interceptor prior to the Eagle, could not shake off the much larger plane. The F-15 could approach 100,000 feet and was equipped with ever-evolving weapon systems. In one experiment, an F-15 climbed to 80,000 feet and successfully blew a satellite out of orbit. By the mid-70s, the F-15 assumed the mantle of the most feared warplane in the world. The F-15E Strike Eagle is the latest version of the airframe. Although it is equipped with state-of-the-art technology, it no longer stands alone. The Air Force, knowing that the F-15E would not rule the skies forever, looked for a more modern fighter. The U.S. once again turned to one of its oldest alliances for the development of that plane. Lockheed, one of the premier United States manufacturers, has worked out of the legendary Skunk Works for much of its existence. Skunk Works projects were so sensitive that its exact location was top secret for decades. Employed by the Central Intelligence Agency and the U.S. Air Force, it had one mission: outdo Soviet technology. Kelly Johnson had been one of Lockheed's top designers since the mid-30s. His vision was legendary. Designing over 40 aircraft, he won 2 Collier Trophies, America's most prestigious award in aerospace. Johnson's designs included the P-80 Shooting Star, the first American jet fighter. Although Johnson was drawing up designs back in 1939, the U.S. Army Air Force didn't take him seriously until 1943. He constructed the P-80 Shooting Star in an astonishing 143 days. One of Johnson's favorite planes was the F-104 Starfighter. Built in 1954, this futuristic interceptor could hold its own against today's sophisticated fighters. Air Force personnel dubbed the Starfighter the missile with a man in it. Despite a lack of high-performance engines, its bullet-like design and minimal wingspan let its pilots enjoy speeds close to Mach 2. Johnson was known for his innovative ideas, and the unusual shape of the F-104 upheld his reputation. The straight wings were much shorter than other conventional planes of its time, and the leading edges were razor sharp. Johnson designed the Starfighter to outmaneuver other planes, not just shoot missiles at them. The F-104 was an outstanding dogfighter and could perform well at any altitude. Though it was light, it was designed to carry an impressive bomb load, including nuclear weapons. The Air Force pressed the Starfighter to meet new criteria, such as ground attack and all-weather capabilities. Johnson obliged. The F-104 met the new demands. The Starfighter, despite its incredible versatility and performance, was never ordered by the United States Air Force in significant numbers. Lockheed instead sold it to 14 NATO air forces, with the last Starfighter being produced in 1983. Kelly Johnson used the design as an inspiration for the renowned SR-71 Blackbird and U-2 spy planes. The Air Force depended upon high-altitude reconnaissance planes to gather information around the world. Soaring above 70,000 feet, it was believed pilots were safe from foreign missiles and fighters. But in May 1960, a surface-to-air missile brought down a U-2 and its pilot, Gary Powers, over the Soviet Union. President Eisenhower and the United States intelligence community were publicly humiliated. The Air Force lost faith in the safety of flying high and demanded a new solution from American industry. Again, it looked to the Skunk Works, which was developing an incredible breakthrough, stealth technology. The company experimented with a single-seat attack plane called Have Blue. The Air Force was so impressed, they ordered a production model, the F-117 Nighthawk. The F-117 was the first aircraft that was invisible to radar. Despite its F designation, it isn't capable of air-to-air combat, but it's used for night attack. Nevertheless, this technological leap eventually led to Kelly's successor Ben Rich being awarded another Collier Trophy. More importantly, it led to Lockheed's developing the F-22, the first true stealth fighter plane. The unusual shape of these aircraft, Lockheed Martin's YF-22 and Northrop's YF-23, come from U.S. Air Force specifications dating back to the mid-1980s. Intrigued by stealth technology, they asked for a fighter that would elude radar. It also needed to be extremely agile and fly beyond Mach 1 for extended periods of time. They asked for the advanced tactical fighter for the next century. The Air Force requirements were difficult to meet. Agility meant large wings, tails, and flaps that could be seen on radar. Cruising in excess of Mach 1 required external fuel pods that would also stand out on radar. Faced with conflicting demands, industry's brightest engineers searched for solutions. 7 different designs were submitted. Each company fought for an advantage, exploring every untested idea, hoping to develop new technology before their competition could. Lockheed Martin and Northrop emerged as the winners. The U.S. Air Force asked them to build prototypes and fly them head-to-head. There are some reports that the YF-23 could achieve higher top speeds, but very little is known of the tests. The Air Force would not release the reasons for its decision, but the Northrop YF-23 did not make the final cut. The F-22 Raptor will be a new challenge to opposing radar, missile, and aircraft designers for the next 20 years. At first glance, the F-22 appears similar to the F-15, but their performance is worlds apart. The Raptor will turn tighter and climb faster than any other American plane. Most importantly, it will disappear from radar. There is not a single right angle on the F-22. Protrusions and sharp angles stand out to radar waves. There will be no antenna, no fuel pods, no exterior weapons. All will betray a pilot to the enemy. All communications equipment and weapons are tucked inside the airframe. Missiles and bombs don't dangle from the wings, but are stored inside the plane's missile bay. Its diamond wing not only eludes radar, but also can hold twice the fuel of an F-15. The F-22 becomes visible when taking evasive maneuvers, such as in a dogfight, so designers made sure the Raptor would be ready. Despite the evolution of guided missiles, the Air Force has insisted on installing a gun. Military planners have not forgotten the problems of Vietnam and will make sure their pilots can cope with any situation. The F-22 was designed and tested on computers. Hundreds of combat missions were flown on the ground. Cockpits and weapons capabilities would astound most veteran airmen. Complex flight controls, data links, radar systems, and multiple monitors can overwhelm a pilot. Much of today's Air Force training teaches pilots to manage the vast amounts of information provided by a plane's computers. Advancements in radar will also allow the F-22 to attack multiple targets before being detected. The F-22 can be seen when its radar is operating, so information will come from elsewhere. A wingman will scan the sky 30 miles behind and beam the information forward via data link. The lead plane is free to target the enemy fighters without being noticed. Each of the Raptor's missiles will track and destroy individual threats before visual contact is established. Lockheed Martin worked closely with Pratt & Whitney to develop a new power plant for the F-22 called the F-119 engine, where afterburners only give conventional fighters short bursts of supersonic speed. The F-119 can maintain speeds above Mach 1 for long periods of time. This is called supercruise. The F-119 is housed within a specially designed intake and has twice the acceleration of the F-15's engine, this without appearing on radar screens. The thrust vectoring capability of the F-22 allows the pilot to perform impossible moves that would stall any other airplane. The F-22's agility will confound any pilot who tries to stay on its tail. In the early 90s, a series of tests were conducted to explore angle of attack capability. Because the engine can change its angle of exhaust 20 degrees up or down, pilots can fly at angles and speeds that stall normal fighters. Even with the nose pitched up 60 degrees, pilots can keep the plane under control. Thrust vectoring is actually a forte of the Russians. Their Sukhoi Su-37 is the only fighter that may be able to outmaneuver an F-22. The Russians have spent more time researching and testing this technology, and the Su-37 can slip away from almost anything in the sky. The United States is looking to develop thrust vectoring one step further. This engine nozzle was built to move in all directions, instead of simply up and down. Without using thrust vectoring, Europe is making its own dramatic advancements in fighter technology. A European consortium is finishing work on the Eurofighter 2000, the future of European air defense. Its cranked arrow delta wing combined with canard wings on the nose give the Eurofighter excellent control at any speed. Europe's new fighter will be prepared for any occasion. Its high-tech guided missiles can destroy targets far away, while its advanced control systems will accommodate close-in dogfighting. France needed a more versatile plane. It created its own futuristic interceptor, the Rafale. Dassault designed the Rafale for both Air Force and Navy needs. Similar to the Eurofighter in shape, it also stresses a super agility and advanced weapons system. Fly-by-wire controls and 30mm cannon combine to make the Rafale deadly in low-speed and close combat situations. The French are making important steps in electronic countermeasures and may soon incorporate voice-activated controls. The United States military, together with NASA, are also interested in improving the way machines interface with humans. Speech and brainwave recognition may only be a decade away. Virtual controls, 3D audio, and G-force experiments are aimed at making the pilot a more effective weapon.
Coming down, got it.
Research continues on the next generation of American fighters. McDonnell Douglas design for the Advanced Tactical Fighter was rejected by the Air Force, but NASA, the American Space and Aeronautics Research Agency, has seen promise in a tailless configuration. Designated the X-36, NASA is trying to exploit the unparalleled agility of the design while using thrust vectoring to overcome its inherent stability problems. A military version of the X-36 would also be stealthy. The lack of a tail would reduce radar cross-section even more than the F-22. Research engineers predict that future fighters will be tailless. To be more cost-effective, NASA has constructed a quarter-scale model. The test plane can climb to 5,000 feet and has validated its claims of extreme agility.
Hear the engine noise?
Nobody's in there, you can see it.
Models like the X-36 and a number of unmanned aerial vehicles already in service hint that pilots may not be needed in planes of the future. The most intriguing aspect of the X-36 is that it is flown in a virtual cockpit. NASA pilots can control the plane as effectively on the ground as they could in the air, which has caught the Air Force's attention. Reconnaissance aircraft like the Global Hawk and the Dark Star may be a window to tomorrow. They are designed to fly missions beyond the endurance of humans and over dangerous territory. These planes are not flown by remote control, but by computers on a predetermined course. If engaged by an enemy fighter, they wouldn't stand a chance. But it won't be long until the Air Force outfits drones with a remote pilot and weapons system. They will make decisions and may be capable of winning a dogfight. Heavy ejection seats and oxygen tanks will not be needed. Fighters will be able to stay aloft for days and pull high-G maneuvers that would disable a pilot. Future technology may allow automated combat aircraft to drop bombs and missiles without endangering the life of their pilot.
Brake release.
Takeoff executed.
Power coming up.
Command is accepted. Brakes release. Power up.
Looking good. We are airborne. Flight number 1.
Today's financial environment has changed the aims of war planners. Where Cold War competition spurred dozens of new fighters and ideas, the 1990s have yielded only the F-22. The new aim is to reduce equipment costs and cut personnel in all 4 armed forces. At the same time, the United States needs to continue to play an active military role around the world. In order to save money, the United States Air Force, Navy, Marines, and Britain's Royal Navy have come together on a plane that will meet all of their close air support needs, the Joint Strike Fighter. Conceived to replace the Harrier, the project is more an experiment in cost-cutting than improved performance. It will incorporate stealth technology and may have vertical takeoff capabilities. Best of all, it will be cheap. With less money to go around, a number of leading companies will work on the Joint Strike Fighter program instead of one designer overseeing the whole project. This may be the future of the fighter industry. Some feel that this cooperation in the face of reduced defense spending could hurt the industry. Less competition may mean fewer innovations and new ideas. At the same time, many companies will consolidate their efforts on one project. This collaboration ensures that the best and brightest the industry has to offer will be brought together on one aircraft.
That's 82.5. Data point is 634, 1507.
The fighter is less than 100 years old. The 20th century has seen more technological advancements than at any time in history. The imagination is the only limit set upon our planes. From the romantic dogfights of the past to an impersonal, digital-driven future, combat aircraft have been and always will be a permanent fixture in the armed forces. We can only guess at the capabilities of fighter planes in the next decade or two. Those enhancements will be the result of a quest for knowledge and a constant pursuit of air dominance.